Line drawings are a way in which we can represent structures quickly and relatively easily while retaining a richness of information about the shapes of the molecules we are drawing. But what are we showing in these structures? And what aren't we showing? And what do the pictures actually tell us about the molecular structures they represent? We're going to start by considering histamine, C5H9N3, an important signaling molecule in our bodies. Drawn as a line structure according to the agreed conventions, histamine looks like this. But if we were to draw every atom in the molecule, histamine would instead look like this. Now that's a fairly complicated alphabet soup, so we take some shortcuts. Let's look at these two structures side by side and see what we do to generate the line structure on the right. The first thing you'll notice about the line structure is that there are no C's for carbon. Carbon is in all of our organic molecules, in many different places, so we don't specify its presence, and instead agree that anywhere in our structure that two bonds meet, like here, here, or here, and at the end of any bond where an atom isn't specified by its atomic symbol, then it must be a carbon atom at that position. Taking the C's out then, the second thing you'll notice is that we don't show most of the hydrogens. Hydrogen is small and relatively unimportant, so we assume its position by default, based on an understanding of valency, and in particular the fact that every carbon atom must have 4 bonds to it in a neutral molecule. So a carbon atom like this one here, to which 2 bonds are shown, must also have 2 hydrogens attached to it to complete the valency of 4. And a carbon atom like this one, to which 3 bonds are drawn, there must be 1 hydrogen attached to make up the total of 4 bonds around that carbon atom. Taking the hydrogens out, that just leaves the heteroatoms to consider. Atoms like oxygen, nitrogen, chlorine and sulfur. Basically atoms of any element other than carbon or hydrogen. These guys are specified by their atomic symbols. So in this histamine example, we see all the nitrogens indicated by the atomic symbol N, or in adrenaline, nitrogens and oxygens are indicated with the appropriate letters. Looking at these finished line structures, you'll see that there is one context in which we do indicate the hydrogens as H's, when they are attached to a heteroatom. So the NH or NH2 groups of an amine show its hydrogens, and the H of an OH is also shown. 2 other quick things before we go. First, a comment about angles. We draw our bond angles to reflect the actual shape of the molecule as best we can within the constraints of a freehand drawing. So around a carbon atom that just has single bonds to it, which we call sp3 hybridized, draw angles that are close to 109 degrees. If there's a double bond to an atom, meaning it's sp2 hybridized, the bond angles should be 120 degrees. And when a triple bond is present, and the atom is sp hybridized, then the bond angle is 180 degrees, giving a linear structure like this. And finally, a note on the use of wedged and dashed bonds like these. We use them when we want to show three-dimensionality in a structure. A thick, wedged line like this one indicates that a bond is coming out towards us. A dashed or hashed line indicates a bond going back away from us, behind the plane of the page. These conventions are important when we talk about the 3D shape of molecules and stereochemistry. So now you know. And let's close with a summary of the guidelines we've discussed for drawing line structures